Hari Om. Today, let us find the relation between current and drift velocity. We know that we have seen earlier what is drift velocity. It is the average velocity with which free electrons in a conductor move when the conductor is connected to an external potential difference. The average velocity with which free electrons move without a battery is called as thermal velocity, and with a battery or a potential difference source, their average velocity is drift velocity. So we have to find the relation between current and drift velocity. As you know, current is equal to charge flowing through a cross section by the time taken for the charge to flow. So let us consider this cross-sectional area, and we will be calculating how much charge is flowing through this cross-section in what amount of time. For example, suppose we know how much charges are present in this conductor. We have considered a conductor of length L. So how many charges are present here? And if we know what is the time taken by all those charges to cross the conductor's this cross-sectional area, we will be able to find the current that is flowing in the circuit. So in order to do that, what we will do, we will consider the last free electron. Suppose there is a free electron which is present on this surface of the conductor. So it is the last free electron. Now the time taken for this free electron to cross this cross section will be able, if we find that time, we will be able to get the time within which all the other free electrons would have crossed. Why? Because first all the other free electrons will cross the cross section, then only this free electron, the last one, will cross. So directly we are going to find the time taken by this last free electron to cross the cross-sectional area. Now think, the velocity with which this free electron is moving is drift velocity. So how will we find the time taken? So t is equal to, as you know, very common formula, distance by speed. How much distance has it to cover? It has the distance L, because L is the length of the conductor. And with what speed or with what velocity is it moving? It is moving with a velocity of Vt. So this is the time taken for the last free electron to cross the cross-sectional area. Now note that here the correct direction of current is clockwise, but electrons, since they are negatively charged, they will be moving opposite, that is anti-clockwise. Now within this time, all the charges present inside the conductor would have crossed the cross section. So our first criteria, that is time, we have got the time within which all the charges will be crossing the area. Now let us find the total charge that is going to cross. So suppose that the number density of free electrons is n. Number density means total number of free electrons divided by total volume. Density means generally divided by volume. So number density means total number of free electrons that are present divided by the total volume. Now so total number of free electrons will be n into V, if we take this V to LHS. So the total number of free electrons will be number density into volume of the conductor. What is the volume of this conductor? If its area of the cross section is A and length is L, as you know, volume is cross-sectional area into height. So volume will be A into L. So this is the total number of free electrons that are present in this much volume of the conductor. And all these free electrons have to cross the conductor in our required amount of time. Now you know that the charge on one free electron is E, or let us denote it by small q. This is the charge on one free electron. Let me represent it as Fe is q. This is the amount of charge present in one free electron. which we know as minus E. So the charge on total number of free electrons, there are total n number of free electrons, capital N. So the charge on them, the total charge will be number of free electrons, that is n, into the charge on one free electron. This is just unitary method. So what is the value of total number of free electrons? NaL into Q. This is the total amount of charge that will be crossing the cross section in our given amount of time. Now we have the total charge, that is Q. We also have the time taken. So let us find the expression for current. So current will be, total charge is this much, NaLQ, by time is L by Vd. So this will become NaLQ into Vd by L. L and L can be cancelled. So this is NQAVD. In most of the books, instead of Q, you will find small e, because they have taken the charge of the free electron to be E. I prefer it to be Q only. This is the relation between current and drift velocity. Let us go a step ahead. If you want, you can express this in terms of mobility also. What was mobility? Mobility was drift velocity by electric field. So drift velocity will be mobility into electric field. Let us substitute this here. So I will become NQA, mobility into electric field. This is the relation between current and mobility. Okay, so with this, let us stop here today. We will proceed to the next part in the next video. Thank you.